moment for us to transition beyond knowledge to gain understanding. This is Uncle Sam, and this is what I basically do on this platform. And I started going live on YouTube recently, talk about concept related to math. Now, in the previous live that I went, we discussed about basic idea behind the indices, and we talked about all the 7 laws that govern indices. And in summary, just for a few recap for those that will be watching this live later on, when we talk about indices, we are mostly talking about the concept of index. And in index in maths, we are talking about path. And so all that is telling us that in indices, we are mostly interested, we are mostly interested in the concept of paths. And once you have a power, the next thing that you should know that you're going to have a base, okay? Every power has a base. For example, if I have a to the power of n, now in this expression, this a here serves as our base, and this n here serves as our power. So what indices tries to let us know is it wants us to represent every given variable or every given number with respect to having a base and also having a power. That is the basic idea behind the indices. And so we went about looking at the several laws that govern indices. And one of the laws that we examined includes, I'll just briefly run through all the laws that we talked about. First, we'll look at the multiplication law, where we say that if I have a variable x raised to the power of n, multiply to another variable, but multiply to itself, which is the same variable, then raised to the power of m. So these two is equal to picking one of the variable because they have the same value or because they are the same. X, what you see here, x and x, you pick one of them because this x here serves as the base, and what is on top for each of them, m and n, serve as their power. So what we're going to have here is that you pick one of the base, which is x, and then you add up or sum up their power. So it's going to be n plus m. So that's how you approach. And this particular way of representing this expression works only if the expression are of the same base. If they are not of the same base, this is not applicable. For example, if I have like x raised to the power of n multiplied to, let's say, p raised to the power of m, this law cannot apply here. We cannot do anything here, okay? That is one of the basic laws that we discussed. And secondly, we talked about the division law, which is to have the same variable x raised to the power of n divided by x raised to the power of m. It's the same thing as picking one of the base, which is what? X, and what? Subtracting the power. That's what you basically do here. If you subtract the power, this is one way of representing it as well. And then the third one that we talked about also is the bracket power law, which is if I have x raised to the power of n, and then the outermost will have another power, m. What you simply do here, you just go about and then pick one of the base or pick the base, and then you go on and multiply the power. Here you just multiply the innermost power to the outermost power, which is n times m, which is same thing as x raised to the power of just m n. That is what you basically do. It's still the same thing. So just making sure that you grasp that. Okay, thank you. Welcome, guys. Emmanuel, welcome. Welcome, Emmanuel. Thank you for joining. Thank you for joining, guys. Thank you. So this is it. Thank you for those that are just joining now. Thank you so much for joining. Really appreciate you. My name is Samson. I go by the name Uncle Sam. And what I basically do on this platform is trying to make being smart the real cool. And my motto is beyond knowledge, transitioning beyond knowledge to gain understanding. And we are just exploring the concept of indices in mathematics, and I try to break it down. So you guys are welcome. Please, can you tell me where you're joining from in the chat? Can you tell me where you're joining from? Do I have a question for Wayek? No, not really, Emmanuel. I don't really have a question for Wayek. I don't really have a question for Wayek. What I'm here to do basically is to give you a sound knowledge and understanding about the concept, and then from there you carry on. You can solve as much questions as possible. What you need is basically understanding, and that is my motto, to transition beyond knowledge to gain understanding. So thank you so much for joining. I'll just continue. I'm just trying to look at briefly, because I already did a live previously 2 days ago where I discussed the concept of indices from start to finish. So I'm just looking at it over again. So what here, the first one I talked about is the multiplication law of indices. We said that if you have the same base and then different power, and then there's a multiplication sign that is separating the two expressions multiplying themselves, it simply means that you can pick one of the base, because since you have xx here as the base, you pick one of the base and then you add up the power. This only works if first the two expressions are of the same base, like you have x here and you only have x here. And then it also works if there is a multiplication here. It doesn't work if there was an addition. So if you have something like x raised to the power of n plus x raised to the power of m, this cannot work. It cannot work. So this is what we basically did. And the next one is the division law, which talks about the subtraction of the powers as well. So what you basically do here, you pick the same base. If you pick the same base, which is x, you subtract their power. So division here simply means subtraction. That is what you have. And then the third law, which I was examining before you guys hopped on, is the bracket. When you have an expression, a base and a power, and then it is enclosed inside of a bracket, and at the outermost part of the bracket on top, you have a power. How do you simplify this? What do you do at this point? Simple. You basically just put your what? The base x out, and then you go ahead and multiply the powers. The innermost power will multiply the outermost power. And then the fourth law that we looked at 2 days ago when I hopped on live is if you have an expression x raised to the power of minus n. Now, this minus simply means negative power. So what do you do in this kind of a situation? You simply turn it into x raised to the power of n. So this is what we know as inverse. Inverse. So what you basically do is it becomes 1 over the same base x, then raised to the power of the n, now positive. So you see, this is another way of representing this type of word expression. Now this is very, very important, especially for differentiation or calculus related problem, because you'll be asked to differentiate expressions of this form. And if you leave it this at this form, you cannot be able to differentiate it efficiently. You need to find a way to turn it. And so knowledge that both these and these mean the same thing is what is going to save you at that point, when you reach that point in your calculus journey in mathematics. So these and these mean the same thing. The next one that we also talked about is the concept where you have that if you have an expression same or uses the same base, which is x, then if it's raised to the power of, let's say, a fraction, let's say 1 over n, 1 over n, it is the same thing as representing this as the square root or the n root of what? X, then raised to the power of 1. So if you have like a fractional power, in this case, x is power of 1 over n, what you simply do is what? You become the denominator of the power becomes the nth root of the base, and then all raised to the power of 1. Now, if you have one of this sort, where you have something of this sort, let me start here, where you have something of this sort, 6, x raised to the power of, let's say, m over n. The same principle that we did here also applies. So it's same thing as saying the nth root, the denominator becomes the nth root, okay? And this denominator can go as far as becoming being 2, 3, 4, 5, and so on and so forth. So it simply means the nth root of the base x, then everything, once you solve for that, everything raised to the power of m. So first of all, you go ahead and attack the innermost word expression by changing this m over n to become the nth root of the base x. Then everything here raised to the power of the numerator, which is m. And then the last law that we actually examined was the power of 0. How that if you have x raised to the power of 0, it is equal to 1. Yes, anything at all raised to the power of 0 will give you 1. How is this possible? Well, we could do a few things to prove why anything or any variable or any number raised to the power of 0 to be 1. So if we pick a variable to prove this, we have something of this sort. if I have 2 raised to the power of 2 divided by 2 raised to the power of 2, we're going to be using the second law of indices to prove that any variable raised to the power of 0 is equal to 1. So in this case now, this 2 here is serving as our base. So since it's serving as our base, this 2 on top here is serving as the power. So for us to prove it, we use the same base and then use the same power. If we go about solving this using the normal division law, this is going to be pick one of the base, because that's the concept here. You see, if you have the same base, you pick one of it, and then division becomes subtraction. You subtract the power. That is what you basically do. So the same thing is what we're going to do here. If you pick one of the base, and then we subtract the power, which is going to be 2, the division sign changes to subtraction. This is going to give us 2 raised to the power of 0. And I said it's equal to 1. But what if we want to go to another route? What if we want to go through another route? We don't want to go through this way. We know that this can also be represented as 2 raised to the power of 2. Then division, we know originally that division is just over. Add another word, this 2 raised to the power of 2. Is this making sense, guys? Is it making sense to you? I'm just trying to prove why any variable, any number raised to the power of 0 is equal to 1. Making sense? Help me, help me. Emmanuel, are you still there? Making sense? Are you guys still with me? Are you guys still with me? Alright. So I'm just going to continue. So at this point here, we know that 2 raised to the power of 2 is same thing as 2 times 2. So this is same thing as 2 times 2 all over, same thing here, 2 times 2. And that's going to give us 4 over 4. And you see 4 divided by 4 is going to give us 1. This is why any variable raised to the power of 0 is equal to 1. So that's what we have at this point. So these are the basic laws that we talked about 2 days ago when I came on live. And I just have to go through it one more time before we go into solving the quick some questions under indices, because that's what I'm here for. Thank you. So I'm going to clean it up now, and then we'll go to solving real examples under indices. So I have a few questions here that we can try out. It ranges from easy to medium and then to hard questions. We'll go about it together. So we have to simplify. This is just for you to get solid ground on the concept of indices, okay? So we have to simplify 2 raised to the power of 1 over 2, multiply to 3 raised to the power of 1 over 2, multiply to 6 raised to the power of 1 over 2, multiply to 8 raised to the power of 1 over 3, multiply to 27 raised to the power of 1 over 3. So this is basically what we have at this point. Can you guys hear me clearly in real time? Please help me, guys. Can you hear me clearly in real time? Emmanuel, can you hear me? Are you still there? Are you still there, Emmanuel? Are you there in real time? All right, I'll just continue teaching. Thank you so much, guys. Thank you for joining. So what we have at this point now is we have 2 raised to the power of 1 over 2 times 3 raised to the power of 1 over 2 times 6 raised to the power of 1 over 2 times 8 raised to the power of 1 over 3 times 27 raised to the power of what? 1 over 3. Now the first step to solving this kind of question is we need to make sure that each of the expressions here have the same base or similar base. And how do we go about doing that? Because this concept of indices, it deals mostly with the concept of prime numbers. So we use the concept of prime numbers to know which base we can actually apply at any given point in time. And how do we go about reducing each of these expressions? I know, and you also know, that 6 is same thing as 2 times 3. So we can actually reduce 6 here to become 2 times 3. Then everything goes to the power of the half that 6 originally came with. So that is very, very applicable. And I also know that 8 is same thing as 2 times 2 times 2, which is same thing as 2 raised to the power of 3. I know this, and you also know this. And I know that 27 is same thing as 3 times 3 times 3, which is same thing as 3 raised to the power of 3. So since we're talking about indices, which largely has to do with the concept of having a base and a power, because indices come from the word index. Okay, so what we're going to do here, we're going to be replacing each of the expressions here with respect to this base and power. So I'm going to go over here, I'll clean it up, or let me leave it. These are going to be 2 raised to the power of 1 over 2 multiplied to 3 raised to the power of 1 over 2 multiplied to, for 6 now, I'm going to change 6, it's going to be 2 times 3. 2 times 3, everything raised to the power of 1 over 2. Then multiply to, I'm going to change 8 now to become 2 raised to the power of 3 because I know that 8 is something as 2 times 2 times 2. I'll switch it up to become 2 raised to the power of 3. Then there is also a power that 8 came with. So I'm going to have outermost here as 1 over 3. I'm going to put the power also here. Then multiply to the last one, which is 27. We have switched it up to become 3 raised to the power of 3. So I'm going to replace 27 here to be 3 raised to the power of 3. Everything raised to the power of 1 over 3. Now the next step to do here, or the next thing to do here, is just to simplify. Simplify. And to simplify it, this expression, I can separate each of these entities multiplying, provided I add their power. So stay with me here. So this is going to be 2 to the power of 1 over 2, multiplied to 3 to the power of 1 over 2, multiplied to this 2 times 3, which was originally 6, that I split. I know that 6 is same thing as 2 times 3. What I'm going to do here is I'm going to separate each of them, each of the variables, each of the numbers, and attach the power that 6 originally came with to each of them. So this is going to be 2 raised to the power of 1 over 2 multiplied to 3 raised to the power of 1 over 2. Why am I doing this? Because since I know that 6 is same thing as 2 times 3, yeah? 6 is same thing as 2 times 3, and there's a power here. So I can actually separate the power and attach it into whatever that is inside of the bracket that I created. So this is for this, both of them. And I'll do, for this, the innermost power will multiply the outermost power, which is one of the laws of indices. When you have two powers, one inside the bracket and one outside, the one inside will go and multiply the one outside. So this is simple as saying 2 raised to the power of 3 multiply to 1 over 3. And then lastly, these 3 will do the same thing. The innermost power will multiply the outermost power, which is 3 multiplied to 1 over 3. So this is what you have at this point in time. And if you have this at this point in time, this 3 will go and cancel this 3. And then this 3 will go and cancel this 3. So that what you have in the end now, you can write it out, is 2 to the power of 1 over 2 multiplied to 3 to the power of 1 over 2 multiplied to 2 to the power of 1 over 2 multiplied to 3 to the power of 1 over 2 multiplied to, here we just have 2, which is something as 2 raised to the power of 1, and then multiply to 3 raised to the power of 1. Now what can I do at this point in time? Simple. Since I've simplified this up to this point now, I'm just going to apply the multiplication law of indices. Why am I doing that? Well, I am seeing similar bases here. 2, 2, 2, they are similar. And also 3, 3, 3, they are similar. So what do you do when you have similar bases multiplying themselves? First law of indices, which is the multiplication law. If you have similar bases multiplying, pick one of the base and then sum up their power. That is what we do. So this is the same thing as saying 2, for the 2, which is the base here, I pick one of the base, which is 2, and then I'll add up the power that each of the base of 2 come with, which is the same thing as 1 over 2 plus another 1 over 2 plus 1. This is what I'm going to do. And then, once I've done that, I will put my multiplication sign and do the same thing for the one that has what? A base of 3. Repeat the same process, which is pick one of the base and then add up the power that it came with. So this is the same thing as 1 over 2 again, plus this for this 3, plus another 1 over 2 here, then plus the one that is here. This is what you have. And if you have this at this point, you can go ahead and what? Add up the powers. Half plus half will give us 1. 1 plus 1 will give us 2. So this is same as 2 raised to the power of 2. I hope that is not ambiguous. That is quite easy. And then multiply to the same thing here. Half plus half will give us 1. And 1 plus 1 here will give us 2. So we now have 3 to the power of 2. You see something that is so elongated, like that was looking very scary at first, we have simplified it because that's the whole goal of simplification. Keep breaking it down by applying some rules. Apply rules that pertain to the given expression. So at this point now, we know 2 raised to the power of 2 because we cannot simply apply the multiplication law for this part. We can't do that. Why can't we do that? Because they are of different base. The multiplication law only applies to a situation where the bases are the same. So what we're going to do here is to convert this 2 raised to the power of 2 to become 4 because this is simple as 2 squared. 2 squared will give us 4. Multiply to 3 squared will give us what? 9. And once we've done that, we just do the normal multiplication, which is 4 times 9 is going to give us what? 36. So you see, we've actually gone through the simplification process, and everything we did here led us to this final answer, which is 36. I hope this made sense to you. Emmanuel, are you still there? This is one of the ways you can simplify indices equation by going through this format. I hope this is clear. So please, I'm going to give like a second for you to take a screenshot, and then I'm going to clean it up and then go to the next question because I have at least 2 more questions to try, 2 to 3 more questions to try, for us to have a better understanding on how to simplify or solve questions related to indices. So I'm going to clean up now. I'll go to the question 2, which is the second question for this particular live session. Let's go, guys. So I have another question that we can try out here, which is evaluate the same thing as solve. 8 raised to the power of 1 over 3 multiplied to 5 raised to the power of 2 over 3 divided by 10 raised to the power of 2 over 3. Evaluate the same thing as solve for this given expression. And now, like we said, this is indices question because we're looking at what? A base, and we're looking at a power. Okay, so I'd say applying the laws of indices, but we can't really do much here. Why? Because each of these values here are in different base. So the first step in solving question under indices is try to make sure that each of the expression given, especially their base, that you reduce it into a base that is similar to each of them. So how do you go about doing that? We know that 8 is same thing as 2 raised to the power of 3. That will give us 8. So if that is the case now, what I'm going to do is replace this 8 with 2 raised to the power of 3. Now, 5 is already in its lowest form. There is no way we can reduce 5 into a number multiplied itself. So 5 is already in the most basic form that it can be. Then we'll go over to 10. We know we can reduce 10 to become 2 times 5. And that gives us a bit of clarity. Okay? And so what we're going to do is to replace each of these things that we did here into this given expression, because that's the only thing that can enable us to solve. Okay? So if we go about exploring this 8 is something as 2 to the power of 3, and then close the bracket, attach the original power that the 8 came with, which is 1 over 3. Then multiply to same 5 raised to the power of 2 over 3 divided by this 10 will be replaced by 2 times 5. So it's same thing as 2 times 5, or raised to the power of the power that the 10 came with originally, 2 over 3. So at this point, we have actually simplified it into something that, we can actually go about trying to solve together. So the next step to do now is apply the bracket power rule in math, which states that if you have a base raised to a power and there is an external power outside, what you simply do is let the internal power multiply the outermost power. And so if you have that, this is going to give us 2 raised to the power of 3, which is the innermost power, multiplied to 1 over 3, which is the outermost power. This is what you do at this point. Then multiply to your 5 raised to the power of 2 over 3, divided by. At this point now, I'm going to do something to the denominator. Since originally we had 10 raised to the power of 2 over 3, and then I switched it all up and said that, so since 10 can be actually broken down into 2 times 5, I replace this 10 now to become 2 times 5, all raised to the power of 2 over 3. So what I can do here is, this power that is here, I can take this power and give the individual numbers that multiply together. So what do I mean by this? I mean I'm going to take this 2, bring it out of the bracket, and attach the power of what? This 2 over 3 to it. Multiply to, do the same thing for 5. Attach the power, which is what? 2 over 3. Yes, you just share the power. Because if I have something like A over B, everything raised to the power of C. This is the same thing as taking the power and attaching to each of the variables. This is the same thing as A raised to the power of C all over B raised to the power of C. So you just share up the powers. That's what I simply employed here to be able to solve this particular problem. So at this point now, what can we do? Well, we continue with our simplification. We know that 3 multiply 1 over 3 will just give us 2 to the power of 1. Because 3 times 1 over 3 will give us 1. Then multiply to 5 here, raised to the power of 2 over 3, divided by what we now have here, which is 2 raised to the power of 2 over 3, multiplied to 5 raised to the power of 2 over 3. This is what we have at this point. So what do we do next? That's the question. What do we do next? Well, if I look at this problem, I think I can be able to apply division of indices. Yes. My camera is inverted. Wow, is it inverted from your end? John. Oh, it's inverted from your end. I thought it was... Wow. I should flip the camera. Oh, I didn't even realize. Oh. I didn't know my camera was inverted. Is there a way for me to... Interesting. If I flipped... I'm losing my front camera. And I don't think it can flip. Oh. Okay. Maybe let me just pause the live. And see if I can do something. Wow. Let me see if I can pause the live. Oh. Maybe that was why most people were leaving. Oh. So sorry. Oh. I didn't know it was inverted. And I can't continue unless I stop the live. Okay, I think I'm going to fix it, but probably in the next live because I'm almost done with this particular question. Let me look at it.